Here, I'm going to demonstrate how to create a fast API Python application and containerize it to be used with Docker in PyCharm Professional. So with PyCharm Professional, we can go ahead and create a new project, and we can select the fast API template, and I'll call it the Docker video hello world. And we can go ahead and select create a main.py welcome script and set the interpreter in Python version to whatever we'd like. We're greeted with the base fast API application, and from here we can go and press run, and we'll see that this application is running on our local machine on localhost port 8000, and we're greeted with a hello world message. Now, the first steps to containerize this is to take all of the Python dependencies and put them into requirements.txt. So we're going to go into our terminal and go and do a pip freeze into the requirements.txt, and now all of our requirements are inside the requirements.txt. To start with the containerization, we're going to create a Dockerfile by going to the root directory, going new file, and go and type in Dockerfile with a capital D, and this will create our Dockerfile that will be used to build the container image. So the first step when we want to build the container image is to base it off of an existing image. So we're going to use the Python 3 since we're using Python, and then we're going to set our working directory to any directory we'd like. I'll just set it to app. Now, once we're in this working directory, we want to copy over to the container, the requirements.txt, to this directory, and we want to run the pip install with no cache there, since we don't need a cache since we want to keep the image as small as possible, and use our requirements.txt. Now, once everything is installed, we want to copy over all of our source files over to this after. Since all of our source files is in the root directory, I'm just specifying dot, but if we had like an app subdirectory, we can specify that. Now once everything is copied over to this app folder, we can go ahead and run the command unicorn main app and set the host to any valid interface and set the port to whatever we like. I'll set it to 8000 here. Now if we click on these arrows, we can then run this Dockerfile, and we'll start building the container. So now that our Docker container is built and running, if we go ahead and click on this URL, you'll see it won't work. And even if we try to go to localhost, it won't work. The reason is this is a container. The ports of the container are not exposed by default. So what we're going to do is first we're going to actually set the Python interpreter to point to the interpreter inside of the Docker container. So we're going to go ahead and go add interpreter under the PyCharm settings in Python interpreter and go on Docker. We're going to select our Docker server to be just our local Docker server. And we're going to build an image using our Dockerfile in the context of this directory, and go next. It's going to build the Docker image. It's all done since it already built it in the last step. And we're going to select an interpreter. Now, there's no need to use a virtual environment since it's just going to add some bloat, and this is already containerized, so the dependencies are already all contained inside of the Docker container. So we're going to go ahead and create, wait for it to prepare everything, and then we're going to go OK. So now if we go into the fast API run configuration, we can go ahead and edit this configuration. Now, one thing I found is that in here, the unicorn options don't respect the ones that are set here. So we're going to go ahead and copy those and put them over into the unicorn options. That's all good. And then we're going to make sure our Python interpreter is set to that Docker one that we made. To order to expose the ports, as I mentioned before, we're going to go into these Docker container settings, open up the folder, and set the port bindings. Add a new port binding. We're going to publish the container port 8000, which is exposed by the fast API. Go to modify options, add a host port if we want, and I'll add the host port of 8000. So this will be mapping the 8000 port on the container to the 8000 port on my local machine. Go ahead and go OK and OK, and press apply, OK again. So now when I run this configuration, now we have our ports mapped. So now if I go back to localhost 8000, we'll be greeted to the hello world message, but we're actually getting these from the Docker container itself. So if we go to this Docker container, we can see this new request is inside of here. So now we go into the docs, we can see the fast API endpoints here. So what's really nice about using PyCharm here and configuring the run configuration this way is that if I stop this and I put a breakpoint into the root, now when I press the debug, once it loads up, now if I go back to this root, you can see it was reset, but it's actually not finished loading because we actually have a breakpoint here on the root. And now if I continue, I can inspect all of the variables I need, and once I press continue, we'll be greeted with this hello world message. So now that we got a simple Docker container out of the way, we're going to go into a little bit more realistic scenarios. So here in our hello world, I've added a SQLite database with a very simple create user and a get user. And all of this is then stored in test.db in the db folder here. In our Docker file, I made two small adjustments. I made run make their /db inside of the app folder, and I'm only copying over the Python files found in our project directory. Now the reason I want to do this is because I want this test.db to be persistent between containers, and the way it's going to be consistent is that it's going to live inside of our project folder rather than inside of the container. So to set this up, once we made this small adjustment to the Docker file and have our db path set in the main.py, we're going to go over to our configuration, and we're going to click on this folder icon again on the Docker container settings, and we're going to add a volume binding. So this will bind a path somewhere on our machine into the container. So we're going to set our host path to this db folder, and we're going to have the container app to be /app/db. We also have the option to set this as read only, but we don't want that for our database since we want to be able to read and write to our database. So after clicking OK, and applying an OK, and make sure our remote Docker is set, OK, we'll then, once we debug this, we can set a debug in our create user path. Well, we can then go to our localhost and go to the docs, and we'll see that we have the create user and the get user. So we'll go ahead and create a user, try it out, call it Chris, and execute. Now we can see we break right inside of our main.py. We can go ahead and add this user and return user Chris has been created. Now, we can see in our database folder, a test.db was made. We can either just double click on it and view the tables, and we can see that Chris was added here, or we can go to this database tab on the right hand side. Here I already have it added, but I will remove it and add a new data source, and we're using SQLite. So add a new SQLite, set the file to this database file. Okay, and now we can see the tables made here, and we can see that this user was created. So now when we stop this container and start it back up, we'll see that our test.db will still stay here on our local machine, but our Docker container essentially connects to this database. So now if we go back into here to the docs and we try to get a user by the name of Chris, we can see we go into this breakpoint, but if we continue the execution, we get the same ID 1 name Chris. Now we're going to explain a little bit more of a full stack application by utilizing the Docker Compose. So by utilizing Docker Compose, we can use other Docker images and kind of tie them together under a single stack so that all of our definitions are within a single stack and can be easily deployed. So in my main.py, I've added a Redis server that we're going to connect to and cache our database gets and puts. Now this isn't a very complex or complete example, but this will demonstrate how to create this Docker Compose. So our Docker Compose is going to consist of this Redis server, and on top of that, an Nginx reverse proxy to actually serve static files on top of that. So as we can see here, I have the static files index.html that I'll want to serve on the root and the same database that we had before. And on top of that, implement a Redis caching. So the first step is going to be to create a Docker Compose. So I've created this Docker Compose that essentially can define services that we'll have. So it's going to be our Python app, a Redis server, and an Nginx server. And this is all under one Docker stack. So in our Python app, what we're going to do is we're going to build with the same context of our project's directory and our Docker file that we've made before. The volume binding is going to be the same volume binding that we've defined in our configuration in PyCharm. And we're going to just set that this depends on Redis. And then this Redis is just very simple. We're just going to use the latest Redis image. We can expose the ports if we want to, but we don't need to. All of these containers are in their own network and can talk to each other freely. And we can see this by with our Nginx, where we use the latest Nginx image. We expose the port 80 of Nginx to 8080 on our local machine, so we don't have to run this with sudo. And we're going to copy, essentially map our Nginx configuration over to where the configuration is supposed to live in Nginx with a read-only flag. And we're also going to map our static files over to the www data directory with read-only. And this depends on the Python app because we'll see. So this depends on the Python app because as we'll see in our nginx.conf, this is a very simple Nginx configuration, but we see that in this proxy pass, we don't use a IP address. Instead, we use the host Python app. With these service definitions here, we can actually refer to these as individual hosts. So for example, Redis, you can see in our main.py, our Redis host is just set to Redis. And this makes the networking between these container images very simple. Now, one thing I had to change in the fast API is to set the root path to /API, since in our Nginx configuration, I set the fast API down to a /API path, and our root path is just going to serve our static directory with the index being the index.html. So to set this up, we're going to go to our PyCharm settings and configure a new Python interpreter. So when we go into this add interpreter, we're going to add an interpreter on Docker Compose. So the first step is just going to select what Docker server we'll use, a local one, what configuration file to use. Are we going to use our Docker Compose? And what service do we want to attach to? So we're going to attach to the Python app. We can leave the rest as B. It's going to build the image, and we can go next. And same as before, we can just use a system interpreter. We'll go and press create, apply, and OK. Now, there's one small catch that I found in the PyCharm. This one, you want to be able to set the Python interpreter to the Docker Compose, not the old one. And one last thing is that you need to set the command and options to up. And the reason for this is that PyCharm will only instantiate the dependencies that are found in the depends on the Python app, but I can't set this dependency to Nginx here because it will create a cyclic dependency. So a small thing to note in PyCharm is to just add this command up. So essentially the only thing it's doing is running the command docker compose up. So now when we debug this, we'll see in our services here that this Docker Compose is now launching the Nginx, the Python app, and the Redis server. And we can see that the application startup complete. So now we can go into the Docker desktop and see that we have this new stack called Docker Video Hello World, where we have our Redis server, our Nginx server, and our Python app all running. And the only thing we have exposed is the Nginx having its port 80 maps to 8080 on our local machine. So now when we go to this, we'll see that we get this hello world that is served from the static file served in index.html. Now what's cool is that since we've bound this to the volume, we can then write whatever we want in this HTML, save it, and we'll see it immediately in our web browser without having to rebuild the whole container. Now, when we go to the /API, we'll be greeted with the same root that we had before. And if we go to the /API/docs, we'll have the same fast API docs as we had before. So now when we set a breakpoint in the create user or get user, we'll get a new breakpoint inside of our PyCharm, with the new addition being the Redis client. So we'll actually set the Redis client to cache this name. Very simple example. And return this user. As you can see, user Bob created. Now, when we try to get the user and we type in Bob and execute, we'll see that we breakpoint into the get user, and we see that our cached user is found in the Redis client, and we just return the user back, and we get a successful message with Bob inside of it.